The Tesla Cybercab might be one of the most unusual vehicles the company has ever created. Still, it's clearly making strong progress, with production ramping up quickly as mass manufacturing is expected to begin in early April. It's even starting to draw more attention than the Model Y and Model 3. Despite that, many people remain skeptical about whether the Cybercab will actually be operational anytime soon. There's still ongoing debate about its design and safety. For example, Elon Musk has repeatedly stated that the final version won't include side mirrors. The versions people have seen with mirrors are mostly early prototypes that are still undergoing testing. The official production model was revealed recently, offering a closer look at the interior and its features. Musk also confirmed that Tesla's Terafab Project will be unveiled soon, essentially a massive next-generation gigafactory focused on producing AI chips, which will power systems like the Cybercab's autonomous driving. A common misunderstanding is what Robotaxi really means. A Tesla Robotaxi doesn't have to be the Cybercab specifically. The term refers to any fully self-driving vehicle that can operate as a taxi without a human driver, similar to services from companies like Waymo or Uber. In that sense, vehicles like the Model Y or Model 3 could also function as Robotaxis if equipped with full self-driving technology. The Cybercab, however, is a vehicle built specifically for that purpose from the ground up. It doesn't have a steering wheel or pedals, and it features automatic wing-style doors. So while Robotaxi is a broad category, the Cybercab is a specific product within it. Now, the idea of the Cybercab paired with full self-driving technology is starting to feel much more real. More of these vehicles are being spotted on the streets of Austin, suggesting Tesla has moved beyond the concept stage. It's becoming clear that this is a product the company is preparing to manufacture and deploy in the real world. With production expected to begin in April, everything appears to be on track. Recently, there's been a steady flow of updates about the Cybercab, including its interior design, hardware testing, transportation activity, and accessibility features, an important factor for public transportation. All signs point to Tesla getting ready for a real-world rollout. One interesting detail is that the Cybercab uses polyurethane body panels with color molded directly into the material. This means Tesla doesn't need a traditional paint shop. According to Tesla's VP of Vehicle Engineering, damaged panels can simply be replaced instead of repaired in more complex ways. New prototype sightings have also revealed upgrades like a larger front camera, improved interior lighting, and other features. Images shared online show that the camera system behind the windshield has been significantly enhanced, leading to speculation that Tesla may be testing a new hardware setup for its full self-driving system, possibly even preparing for a future AI 5 generation. Although the AI 5 computer isn't expected to reach mass production until around mid-2027, the larger camera lenses suggest improvements in Tesla's optical sensing capabilities. These upgrades are likely aimed at increasing accuracy and environmental awareness, which is crucial for a vehicle like the Cybercab that relies entirely on autonomous driving without manual controls. Some images also highlight larger lenses and small separators between the front-facing cameras, further suggesting refinements to the vehicle's perception system. Unlike companies like Waymo that rely heavily on LiDAR, cameras are essentially the backbone of the Cybercab system. The larger front cameras are just one part of a broader hardware upgrade. Images believed to show the final production version reveal a large cabin-facing camera along with another camera placed in the trunk area. This rear camera is likely designed to check whether passengers have left any belongings behind after a ride ends. While that might seem like a small feature, it's actually very important for a fully autonomous robotaxi. Since there's no driver, the vehicle needs to monitor the cabin on its own after every trip. Tesla has also made several interior changes to improve durability, and handle frequent use, something essential for a robotaxi that will serve multiple passengers throughout the day. For example, the storage area that was previously carpeted has been replaced with a hard, non-carpeted surface. This makes it easier to clean and more practical for constant use. The placement of controls is still being refined. In some versions, the window controls and USB-C ports are located just below the 21-inch central touchscreen. However, another version displayed at the U.S. Department of Transportation had these controls positioned closer to the cup holders on the center console. This suggests Tesla is still finalizing the interior layout. Overall, the Cybercab maintains a very minimalist design. Inside, there's only a single emergency stop button placed above the center screen. Interestingly, this button includes Braille text to ensure accessibility for all passengers. At the same time, Tesla has added subtle touches to enhance the cabin experience. Thin, ambient lighting strips run along the door frames, emitting a soft blue glow in recent images. This not only gives the interior a more modern and premium feel, but also serves a practical purpose by lighting up the entry and exit areas at night. This kind of detail is especially important for a 24/7 autonomous ride service, where both safety and passenger comfort must be maintained in all conditions. Beyond the interior and camera upgrades, newer Cybercab prototypes closer to the production version show several hardware improvements that reinforce its role as a high-end robotaxi built for continuous operation. One standout feature is its asymmetric wheel setup. The rear tires are larger and wider than the front ones, a design often used in high-performance vehicles to handle the strong torque of electric motors. The front tires are sized at 215/60R18, while the rear uses larger 225/60R21 tires, improving traction and acceleration. The wheels are fitted with Continental Eco-Contact tires and aerodynamic covers. This combination not only enhances the car's appearance, but also reduces air resistance, improves energy efficiency, and provides better stability on the road. Tesla has also equipped the Cybercab with a high-pressure cleaning system for its exterior cameras. This ensures the sensors maintain a clear view even in rain or dusty environments without needing manual cleaning. Some early test vehicles seen at Gigafactory Texas still include mirrors and steering wheels, but that's mainly to meet local testing regulations. The final goal remains a fully autonomous design with no steering wheel and no side mirrors. So if you spot a prototype with those features, it's just part of the testing phase. As production approaches, these ongoing refinements show that Tesla is putting strong emphasis on improving the reliability and performance of its self-driving system. Mass production of the Cybercab is expected to begin within the next few weeks. At the same time, Tesla is approaching a major milestone with its ambitious Terafab Project, a large-scale in-house semiconductor manufacturing initiative. Recently, Elon Musk shared on X that the project would launch in 7 days, pointing to an official start date of March 21, 2026. For context, Terafab is designed to operate on a scale far beyond Tesla's well-known gigafactories. The goal is to build a massive AI chip manufacturing facility in the United States, capable of producing over 100 billion chips annually, potentially even up to 200 billion. The facility is expected to handle everything in one place, from chip design and memory production to advanced packaging, giving Tesla full vertical integration in semiconductor manufacturing. This project is being driven by Tesla's rapidly increasing demand for AI chips. The company is already developing multiple generations of custom processors, including AI-5, which is expected to enter mass production around 2027, followed by future versions like AI-6 and AI-7. These chips will power a wide range of technologies, including Tesla's full self-driving systems, its humanoid robot Optimus, and the Dojo supercomputer used for large-scale AI training across Tesla, xAI, and SpaceX. Musk has repeatedly pointed out that current chip suppliers like TSMC, Samsung, and Micron Technology may struggle to meet Tesla's future demand. He's also warned about ongoing challenges in the semiconductor industry, including shortages of power, transformers, and cooling systems for AI data centers, issues that could persist for the next 9 to 12 months. By building Terafab, Tesla aims to take control of its chip supply, reduce reliance on global supply chains, and strengthen domestic semiconductor production in the U.S. From an investment standpoint, the project could cost tens of billions of dollars, with some estimates around $25 billion. It also carries significant risks due to its complexity and long development timeline. However, if successful, Terafab could transform Tesla from primarily an automaker into a fully integrated AI and semiconductor company, comparable in scope to industry giants like Intel or Samsung, while reinforcing its position in the global AI and robotics race. It could also create thousands of high-quality jobs and reduce dependence on overseas chip manufacturers. The upcoming launch phase may not mean immediate production. Instead, it could involve early steps such as construction, detailed engineering design, prototype testing, or announcements about location and partners. Even so, it signals that Tesla is seriously moving forward with this large-scale vision. Shifting back to the robotaxi space, Tesla is no longer just competing with Waymo. A new rival has entered the scene: Lucid Motors. Known for its luxury electric sedan Lucid Air and impressive battery efficiency, Lucid has unveiled a new robotaxi concept called Lunar during its Investor Day event in New York on March 12th. Lunar is a fully autonomous two-seater vehicle with no steering wheel or pedals. Built on Lucid's upcoming midsize platform, it features a minimalist yet spacious interior designed for passenger comfort, with a sleek and futuristic look that clearly positions it as a competitor to Tesla's Cybercab. Lucid claims that Lunar will achieve an energy efficiency of around 5.5 to 6.0 miles per kilowatt hour, which is significantly higher than many current EVs. The company also states that the vehicle can gain over 200 miles of range in just 15 minutes of fast charging, while reducing operating costs per mile by up to 40% compared to traditional ride-hailing services. These claims are aimed not only at improving the economics of autonomous ride services, but also at showcasing Lucid's strengths in hardware, especially its advanced battery technology and the new Atlas drivetrain system, which the company says continues to set benchmarks for efficiency. The Lunar concept isn't intended to be a standalone product. Instead, it serves as a preview of what Lucid Motors plans to build on its upcoming midsize platform. This platform is expected to support 3 future consumer vehicles, including 2 SUVs named Cosmos and Earth, along with a third model that hasn't been revealed yet. Lucid has also made it clear that this platform is being designed to handle both personal vehicles and autonomous commercial use. The company is reportedly in advanced talks with Uber to deploy vehicles based on this platform at scale, similar to its earlier Robotaxi initiatives. This indicates that Lucid is aiming for more than just a Cybercab-style vehicle. It's working toward a broader ecosystem that combines affordable EVs with autonomous ride services. That said, there's still a big gap between concept and reality. Lucid has confirmed that Lunar remains just a concept for now, with no active production program underway. Although CEO Mark Winterhoff initially suggested development was in progress, the company later clarified to media that no dedicated robotaxi production project has actually started. Meanwhile, Tesla has made more visible progress in the robotaxi space, Public reaction to Lunar has been largely skeptical, with many online comments dismissing it as a CGI-style imitation of Tesla's Cybercab, lacking real autonomous driving capabilities. Some observers point out that designing a concept vehicle is relatively easy, but building a reliable, scalable self-driving system is far more difficult. This is where Tesla currently has an advantage, with its full self-driving technology already being tested across multiple cities and supported by billions of miles of real-world driving data. While Lucid is widely respected for its battery performance, especially with the Lucid Air, which once held the record for longest driving range, it still appears to lag behind in autonomous software development. In a recent interview at the Prosperity Summit 2026, Elon Musk shared a broader vision for the future of artificial intelligence, robotics, and the global economy. His comments went beyond Tesla's current products, outlining how AI and robots could fundamentally reshape how people work, produce goods, and organize society. One of the key highlights was an update on Tesla's humanoid robot program, Optimus. Musk revealed that the company is now entering the final development stage of its third-generation model, Optimus 3. He described it as potentially the most advanced robot in the world once released. Tesla plans to begin limited pilot production this summer to fine-tune manufacturing and test performance. If everything goes as planned, mass production could begin by summer 2027. The company is also preparing around 10 million square feet of factory space dedicated specifically to robot production, showing just how ambitious this project is. Addressing concerns about job losses, Musk stated that Tesla does not plan to replace workers with robots. Instead, he views robots as tools to support humans by taking over repetitive, physically demanding, or dangerous tasks. This would allow people to focus on more creative and higher-value roles, potentially driving productivity to new levels. Musk also spoke at length about the rapid growth of the AI industry. He believes the field is entering a phase of accelerated expansion, with breakthroughs happening faster than ever. One major milestone he highlighted is the idea of fully automated, recursive self-improvement, where AI systems can train and improve themselves without human input. According to Musk, this level of automation could become a reality by the end of this year or sometime next year. He also mentioned the latest AI model from xAI called Grok 4.2, which he claims is currently among the best in the world at predicting outcomes across many domains. However, he acknowledged that xAI still lags behind some competitors in programming capabilities. In fact, Musk noted that he arrived late to the interview because he had been leading an intensive engineering meeting focused on improving performance in that area. Musk expects that xAI will catch up to competitors in coding capabilities by around mid-year. Looking at the progress in robotics and AI, he shared a bold vision for the future of the global economy. He suggested that once humanoid robots can produce goods and deliver services at a rate far faster than the growth of money supply, the cost of living could drop dramatically. This could lead to a period of large-scale deflation, where goods and services become extremely cheap and widely available. In that scenario, Musk envisions a society moving toward universal high income, where people enjoy a good standard of living without the intense competition for resources that exists today. He even speculated that in the far future, money itself might no longer be central to society. Musk imagines that governments could simply distribute money to citizens because AI and robotic production would be sufficient to meet society's needs. In such a post-scarcity economy, he believes superintelligent AI systems would no longer focus on currency at all, prioritizing physical resources like energy, computing power, and the ability to manipulate and transform matter.